a ball is made to go in a circular motion. You can say it's a plastic rope tied to the ball, and the ball is made to go in a circular motion at a constant. The speed of the ball is constant. We have seen this motion before, and we call it uniform circular motion. The magnitude of the velocity was constant, but the speed was constant, but the direction of velocity kept changing. Therefore, there had to be an acceleration, and that acceleration was called centripetal acceleration, right? So that we have already seen that centripetal acceleration A is given by v squared by r, where v is the magnitude of the velocity and r is the radius of the circle. The direction of acceleration was along the radius, directed towards the center of the circle, right? We also could express centripetal acceleration in terms of angular quantities, where we said this was equal to omega squared r, and the relationship between v and r was v is equal to omega. Now, if there is an acceleration happening, there has to be a force. Newton's second law, that's sacrosanct. An acceleration is happening, there is a force. This is the acceleration. Therefore, the force is equal to mv squared by r, where m is the mass of the ball, v squared by r is the acceleration. Or in terms of angular quantities, m omega squared r. So therefore, the force which makes a ball or makes an object go in a circular motion is called centripetal force, right? Now, there are innumerable examples around us when we look at circular motion. The first one, of course, could be what you just now saw, a ball going around in a circle. The earth goes around the sun in a circular motion. The centripetal force is given by gravity, right? Electrons go around the nucleus of an atom. The electrostatic force is the force which gives the centripetal acceleration. And another common example is maybe you have seen a car take a circular curve, right? Many times you see a car come speeding around and taking a circular curve. What is giving the acceleration here? The friction. The friction is acting as a centripetal force such that the car can take a circular motion. You may have seen a car skidding also trying to take, or maybe on your bike you had a skidding experience when you try to speed around a circle. So what is the maximum velocity with which a car, or what is the maximum speed with which a car can take, go around or maneuver a circular curve? Okay, so that's what we're going to explore over here. And for this, we need the concept of both. We use both concepts from centripetal force and friction, right? So when we have a car here, it's going around, right, in a circular motion. Assume that it's going around in a circular motion. We know there is the forces acting as mg, and there's a normal force acting upward. There is the force by the road, or the earth exerted onto the body. There is not by the earth, by the road onto the the reactional force onto the body. And as it goes around, we know that there's a friction force acting here, right, which provides the centripetal acceleration. So we can say friction is equal to mv squared by r, right? Now, friction we saw is an adjusting force from zero. It can go on till it reaches a maximum force, right? And a maximum condition or the maximum frictional force is given by mu n, right? And when we look at the vertical motion, there is no acceleration in the vertical motion. Therefore, we can say n is equal to mg. Therefore, the maximum friction is mu mg, right? Therefore, if we were looking for the limiting condition, or what is the maximum speed with which the car can maneuver the circle, you'll find that the frictional force mu mg should be greater than or equal to the maximum, the centripetal force at maximum velocity, right? This is the condition for to ensure that the car does not skid, right? Cancelling m from here and rearranging the terms, I bring v squared to the side. V squared is less than or equal to mu rg, or I can say v is less than or equal to root of mu rg. In other words, this is the maximum velocity, the speed with which the circle can maneuver, the car can maneuver, or your bike can maneuver a circle. If you go more than this velocity, it's going to skip because the frictional force does not provide enough centripetal force to make the car go in a circle, right?